So most of the world still thinks of AI as something that we talk about, that we interact with on a screen. But the real transformation in AI is, as we know, coming off the screen and into the physical world. In robots, factories, logistics networks, vehicles, critical infrastructure. That shift changes everything, right? From this speed of decision making, the scale of operations, and the nature of risk. When AI goes from insight to action, mistakes stop being digital, they turn physical. And the big question becomes, how do we build systems that are not only capable, but trusted, secure, resilient, and aligned with human intent? And as a warfighter, I'm very optimistic in many ways, but I am concerned about the separation of humans from the realities of killing. When we do that, we're going to transition and allow the machines to be intermediaries for the humans. We outsource decision-making, we lose human agency, and warfare becomes a slave to autonomy. Now, this isn't all pessimistic, of course. Like I said, I'm optimistic in many ways, but I do think that we need to understand how AI can assist us and how at times it can replace us, but it should not be replacing human agency. So I'm really excited to talk to the experts here on the panel, and we'll jump right in. Thank you all for joining us. The first question is really describing in each one of your sectors, right, like how AI is going to go from insight to action, how it's going to impact the physical world where you all are sitting. So we'll start over there with Jim and move down.
I'm James Kuffner. I'm the CTO at Symbotic. And at Symbotic, we move over 8 million boxes a day in warehouses. We have a fleet of over 20,000 robots. They each drive about 50 autonomous miles a day. So we're doing over 1 million autonomous miles every day, more than Waymo or any other company. And it's very exciting, I think, to see how physical AI embedding this intelligence to create real value. It's basically allowing our supply chain to become more efficient and lower cost, so we can lower the cost of food and household goods for people all over the world.
Yeah, James, thank you. I had a quick follow-up too. I'm just curious, what do you think is the hardest part of like making AI real in robotics? Do you think it's the perception? Is it the planning, safety certification, fleet level orchestration? Like, what's your perspective on that?
I've been working in robots for about 35 years, and I started out doing a lot of motion planning. But what I realized that it didn't matter how great my motion planning algorithm was, if the perception was wrong, the robot would do the wrong thing. And so we really needed to get perception to work. And that's why I think we've really seen computer vision start working. We've seen compute come online that can do things in real time. And now we're seeing robots move out of structured environments like factories into semi-structured environments like warehouses. We still have a huge amount of uncertainty that we have to deal with, but and eventually the AI will get so good they'll be able to handle unstructured environments like homes and offices. But right now, I think there's incredible opportunity in places like warehouses where you don't have different kinds of weather. You have, consistent lighting, but you have a huge variation in packaging. For example, there's damaged boxes or product leaking, many, many things, a long tail of low probability things that the robot has to reason about. And that is actually where I see a huge amount of value that's happening.
Awesome. Thank you. All right, Adam, over to you.
All right, thanks. So CrowdStrike is a cybersecurity company, and we actually sit at the intersection of where the good guys are using AI defensively and where the bad guys are using AI offensively. And we've seen an uptick in the use of AI by threat actors ranging from, do I have to say at ease?
At ease.
It's more polite if he does it. I'm from New York. I'm just gonna come off the top rope. So we sit at the intersection of good guys using AI and bad guys using AI, and threat actors like North Korea are using AI every day. In fact, last year we stopped 700 North Korean threat actors getting jobs, remote IT jobs, across various industries using AI to get resumes that will be attractive to recruiters, using AI deepfakes when they do the interview. And then once they get the job at a Western company, using AI to actually develop code in order to get multiple jobs so that they could work 100 jobs in a day and generate revenue for the regime. On the flip side of that, defensively, I'm pretty excited because we're at a point, there's this concept in cybersecurity of the defender's dilemma, where the defender has to be right 100% of the time, and the adversary only needs to get lucky once. And that's very difficult as more and more threat actors enter the fray for the defenders to keep up with. They're getting overwhelmed. They're getting burnout, very much like an air traffic controller might get burned out looking at that screen. And so with AI, we can actually offload a lot of that work and allow the defenders to scale and to match the speed of the adversary, because every year these adversaries are getting faster and faster. In fact, last year, the fastest we saw an adversary go from getting access to one machine and moving to a second machine was 51 seconds, which is faster than any human analyst is going to be able to identify it. So AI is kind of the cause of and the answer to all of our problems.
Yeah. Thank you for that. Osa, I'd love to hear your perspective on this.
Well, so I work for Ericsson, and we are the leader when it comes to 5G and cellular networks, and also the largest contributor to the 6G standard. And for us, AI is important in many ways, but one is, as we scale this very complex logistics, we use robotics, we use sensors, we want to be able to detect threats quickly. Actually, the network and the connectivity that needs to support all of those devices, from drones to humanoids to sensors and a wide range of applications. You just don't want your best effort network that works for your cell phone sometimes here in Davos to be that what you rely on. So we use AI. We built our networks, the current and next generation, to have programmable deterministic networks. That means it's actually programmable, deterministic for every single application. So you can decide, is that an application that require a lot of capacity? Is that the kind of application that require a reaction time that is faster than a human mind can react? And obviously, investing and building that, you could say, network platform out at scale, we think is critical also to support other enterprises, every industry, to really leverage AI and physical AI to its full potential.
Yeah, fantastic. We will talk a little bit more about some of the risks that we're facing. All right, Peter, over to you.
Yeah, so I think we're yet again here in Davos discussing a term that we would probably need to define: embodied intelligence or physical AI. I'm co-founder and CEO of a company called Silo AI. We founded the company in 2017 as a private AI lab. Before the current AI wave, and very different story. We didn't raise billions. We bootstrapped the company. We looked for the initial sort of pockets in the market where the technology is mature enough and the market is mature enough. And actually sort of most of that happened in edge and embedded computing. So, we started off with self-driving and autonomy-focused AI back then, and then obviously sort of moved on from one segment to another and ended up in Gen AI and LLMs and what everyone is doing today. And obviously now we're seeing that converge back to robotics and what we call physical AI today. And then eventually we were acquired by AMD in 2024. So currently Silo functions as AMD's global AI lab. One of the core focus areas is robotics and automotive. Of course, we're working on LLMs, we're working on frontier models with all of the big frontier model builders, but we're also working on robotics and automotive. And AMD obviously puts us in a unique position where AMD is not only providing AI compute in terms of GPUs, but also embedded and edge solutions, also adaptive computing, and then allowing sort of that sort of cloud to edge transition to happen.
No, thank you for that. Where do you see the largest constraint that you guys are facing when we're talking about, trying to get these AI systems into physical machines or?
Yeah, I think what James briefly touched upon, which obviously is a much larger topic, but where, it's easy when the area where that defines the physical world is well constrained and not changing. But that's usually not the reality in most use cases. And that's kind of what the world has seen for the past 10 plus years, when the world has been chasing full self-driving or other specific applications in environments that are changing. And then, if you take that all the way to defense,
where the adversary has as its main task to basically change the environment. In most cases, the reality is that AI breaks. And then the question is, how do we build sort of adaptive approaches to AI that are self-learning to the extent that they can actually also operate in an environment that is changing?
Wonderful. Thanks for that insight. All right, Steve, over to you.
Thanks, Tucker. So as Tucker said, I'm at the Stanford Robotics Center, and there's a lot of different work that goes on at Stanford. I'll talk about two things briefly and the kind of the way that AI plays. So one of the projects that's near and dear to my heart is robots for older adults and robots to help people with disabilities. And I think the key lesson here is that while you want to use AI to enable people to talk to their robots, to their devices, to their helpers, you don't want to give the agency over to the AI. You want to leave the agency with the older adult, with the person with disabilities, so that they're in control of their life. That's really the whole point. So you do want this caregiving ability, but you want the user to be able to direct that care. And so the AI needs to take a kind of back seat. The other project I think is interesting is looking at manufacturing robots, and kind of we're thinking about how do we transform manufacturing in the next decade. And one of the interesting things when you talk to manufacturing people is we want to process. We want to make sure that the second one is built exactly the same way as the first one, and everyone comes out exactly the same. So you don't want AIs kind of winging it. You also don't want, if you have humans doing assembly, you don't want them winging it either. You want them to follow the process. But you still need AI to help you figure out what the process is. And that's exactly akin to when we use Copilot to have robots help us program, but we're just going to take it to the next level and let us program an entire robot system to do manufacturing.
No, I appreciate that. I do think that there's that balance between assisting and replacing. And at some point, it's somewhat precipitous. If you assist so much, have you in the end actually replaced and then turn to idiocracy or something like that, right? Which is, a concern, at least, I think, in general.
Great movie too.
It is. It's prescient, it seems, maybe. All right, I'm going to talk about risk now. I'd like to kind of get your opinions on what is the most underappreciated risk, so technical or operational or societal, of putting AI into real-world systems. And I'm actually going to start with Osa here. And I'm curious if it's like connectivity, or how are you seeing it from Ericsson?
Well, all right. I think when it comes to risk, I would maybe turn around. I think I'm a very much believer that you should not just
Eddie's.
you should not just let the language model run on its own. It's very much, as someone said the other day, it's like having the English teacher managing your fighter jet, right? You don't want that, but it's a great interface. So I think the biggest risk is that we simplify the whole intelligence concept. I think where this becomes really interesting is when you can leverage that interface and make it more accessible, and you can have access to your proprietary data, your proprietary intelligence, contextualize it, and have that still oversight curated. And over time, you can probably automate, you can actually train the agents so well that they can act as you would and optimize it so it would act even better than you would. But what I think you want to make sure is human values, human integrity needs to be kind of, back to your point, the agency, right? For how we run and manage and build those products, those systems. And I think it's less about the network in that sense. I think the risk with the network is actually that it gets the assets and the network and the security that helps your backbone, that it gets overlooked. And that I think is a bit fun these times. I'm working in the boring industry because we're the industry when things are not working, you get annoyed. You just want it to work, but otherwise you don't care so much. I think every company who wants to apply this system needs to think carefully, what is the infrastructure backbone from, your cloud, your compute, to your connectivity, to your cybersecurity. So you actually have a stable, a very resilient, well-performing backbone so you can focus on what you really should do.
Yeah, no, so important. And there is an interesting difference here because that is very important for our society. But now I have a reality when it comes to warfare, and I have systems that are on the edge autonomous intelligence, a term coined by a CEO of Tyco AI, Tom Keeney. I don't know if he coined it, but he uses it all the time. But the idea is we have systems out there that are disconnected, that they are not able to connect. And so how do you develop the infrastructure to establish that type of architecture and still have government or operator oversight? You don't have to answer that rhetorical somewhat. I mean, if someone wants to jump in, but yeah, that's a challenge that I think we're facing.
But I actually think there is a case where that has been implemented at scale, and that's China. And China is the only place right now where you have the stack from the connectivity layer, cloud, compute, all the way to devices and applications. And actually it's rolled out all the way to the edge. In Europe, North America, that has not happened. We have pieces, but it's been developed horizontally. So that full optimization and the full scale of the platform has not happened yet. And that's what we're working on now with a lot of tech partners outside of China, globally, to say how do we establish that trusted stack and how do we scale it? Because to your point, it's underdeveloped at the edge. And you would say many devices and sensors are not even ready or enabled to be connected in a way you can easily access it.
Yeah. Adam.
So maybe jump in real quick because I think the human agency aspect of this is certainly an interesting challenge. But AI is being implemented everywhere, whether your fitness tracker has AI built into it or your F-22 or F-35 have AI built into it. Enterprises are moving to using AI across all of their systems as well. And one of the big concerns is trust. Because right now, if a threat actor hacks into your environment and they get access to your AI, they're trusted. That AI is trusted, and AI becomes the new malicious insider in your organization, in your enterprise. So while the human agency is one side of the trust and kind of security and safety issue, I think the other side of that is how do we know who's interacting with that AI, particularly as it becomes agentic and it can take physical actions, whether it be robots or weapons systems or, SaaS systems or things like that, that if somebody abuses that, there's no security measure to even see, did a human initiate this transaction and is this authorized?
Yeah, no, trust for me has been the biggest thing because we've been adopting life-saving autonomy technology in aircraft for a while, where the autonomy will take control away from the pilot, and pilots don't trust that. It took them decades actually to realize that it's going to save their life. And now, as you adopt other technologies, there's that tension and balance. You don't want to overtrust, but you also need to understand the realities underpinning, like this capability is real and it should be trustworthy to an extent.
And audit the actions is, I think, the critical part, right?
Yeah.
Because if the F-35 turns around, is that because it realized that there was a safety failure?
Yeah.
Or did some foreign adversary gain access to the system and redirect it?
Yeah, 100%. Love that. Peter.
The original question was about risk, and I am an optimist, so I do believe that there are many ways that we will tackle those risks. Eventually, could be through regulation or other means, but I think the single biggest risk when it comes to physical AI today is really sort of technological, in the sense that are we actually creating value with these technologies? Are they actually being utilized in the real world? And they will eventually, but I think we've seen how difficult it actually is to put full self-driving on the road, and this we are seeing in so many different application areas. And what I sort of thought I would, and we can have a longer discussion later on weapon systems and defense, but while it's sort of easy to build technology that is great technology, which is demonstrated in peacetime and works in peacetime, it's actually difficult to create technology that works in wartime. And that's what we've seen in Ukraine and how they actually tap into these technologies. And usually sort of the way that you actually solve problems, as much as I've seen, is that you narrow down the problem. And in many cases, the unmanned systems that are being deployed are quite mission specific. rather than trying to generalize to all specific environments. And I think that applies to many different physical AI applications out there.
Yeah, that's good. That's an aha moment for me. I like that. Narrow application, really important. All right, James, I'm going to turn to you because I hear that we're all going to have Optimuses in the next 2 months in all of our houses from certain individuals. I'd love your take on, the embodiment of AI in these systems, the risk involved. Is it, robots falling over, hurting people? Like, what are your thoughts?
Yeah. So I used to tell my teams, it's one thing if your phone crashes or your web browser crashes. It's a completely other thing if your car crashes or your robot crashes, because it could harm a person. So we need to have a very high bar in terms of quality of software and technology. AI is a very powerful tool. How do we leverage that power to ensure the quality of our software? And also, I come from a classical robotics perspective where we would design Lyapunov functions to guarantee that a system, a dynamic system with bounded inputs, would generate an output within a bound. So you could actually bound and reason about the output of the system. And then when neural networks got thrown into the mix, suddenly there was unbounded outputs. And so we need to actually not lose that mathematical rigor and the amount of functional safety that we embed into systems like autonomous cars or robots. And I think if we keep that high standard, then we'll be able to really, truly get value out of these physical AI and embodied AI.
Yeah. Yeah, I do think that as a test professional testing aircraft and weapon systems, the test of these systems is going to be super important. And then developing metrics to know how it's doing is also a huge challenge because it's not like our deterministic code of past. So, okay, love that. All right, Steve, over to you.
So I'll actually go back to my last company, which was called Savioke. We were building little autonomous robots in hotels. And just to give you a sense of so safety is the risk I worry about. And just to give you a sense, when we look through the robot's cameras in the early days of deployment, we see these little toes, little 3-year-old kids coming up barefoot, hugging our robots. And that's set like a pretty high safety bar. And we realized that what we really wanted to do was make sure that even if a hacker broke in and had control of the robot, that they couldn't cause harm. Now, you can't always build a robot system to do that, but that's like the goal is to say, like, this robot will never go so fast that it would knock the kid over. This robot, even if this one sensor system fails, is still not going to fall down the stairs, right? And when you analyze the different things that can go wrong carefully, and you put in a layer of safety, and then you can let the AI run above that as though it's in the same space that you would, in the worst case, have a hacker acting. And so the AI can be a bad actor, can be a good actor. Most of the time it's fine. But the worst you get is unexpected behavior. You don't get injuries.
All right, we're almost out of time. I'm going to do some lightning questions. Do you guys have a few seconds to answer them? Just whatever's off the top of your head. Name one thing you believe about physical AI that most people here are underestimating.
Culture.
Oh, say it again.
Culture.
Okay.
The difficulty to generalize.
You don't have to add anything if you don't want to.
Handling uncertainty.
Yeah, I would say safety again.
Okay. And if you could write one like global norm for autonomous systems, what would it be?
Explainability.
Okay. Safety, I think, is probably the number one thing from my perspective.
Yeah.
Trusted, resilient backbone.
I'll also go for safety.
Yeah, and just to be different, I'll say keeping the humans in control.
Yeah. You don't care about safety.
No, I do care about safety.
I'm kidding. Fantastic. Well, it was really great, talking very shortly with you all. Your expertise is phenomenal. Hopefully you guys garnered something from that. It looks like
I'm going to ask, so everybody here more on the physical world. Self-driving, would you get into a self-driving vehicle?
I love Waymo.
Yeah, me too.
Oh, here's a better question from a pilot's perspective. Are you cool with the commercial airliners being landed, piloted basically by robots?
Isn't that already happening?
I defer to you. Tell me if it's okay.
I assumed it was happening.
I heard it was actually more safe to land when you have zero visibility and high wind You let the computer land.
Yeah, in fact, that's kind of the future with some of these things being more effective than pilots. Not me, of course, other pilots out there. All right, we're past time. Thank you all.